Let's solve this problem which involves northern and southern hemisphere. So this is a point A. The latitude is 20 degrees south and a longitude is 24 degree, or I can write 0 to 4 degree 30-minute west. Now the point B is 35 degree north and longitude is 1 to 0 degree 30-minute east. So we need to see which direction we are going. From south you are going to go to north, so this direction is north. Now here from west we are going towards east, so the D long here is 145 degree. I need to add 24 and 120 plus 30 and 30, which is 1. So the result is this, and the direction is towards east. There is no need to calculate DLAT, although you can calculate. Now let's see how these points are placed. Suppose this is equator. Let me just mark equator. So this point is A, which is 20 degrees south. Say this is point A, and point B is 35 degree north. That means point B is somewhere up, but the direction is east, so the point B is, say, somewhere here. How the curve will take place? In southern hemisphere, the great circle curve is like this, and in northern hemisphere, great circle curve is like this. So suppose there is a pole here. Now I can join these 2 points, this way and this way, and this fellow being equator, that is a 0 degree latitude. So now this is 20 degree south. So from equator, this point, let me mark this curve. From this point to the pole is 90 degree. So the total PA from P pole to this point A is 90 degree plus 20 degree, that is 110 degree. Similarly, let's mark this way. So this is equator, and from equator to B is a 35 degree. So this side will be 90 degree minus 35 degree, which gives me 55 degree. So I have a spherical triangle in which these sides are given. This PA is 110 and this PB is 55 degree. All I need to do now, I need to calculate this great circle distance. Well, again I can use this formula, which is cosine of AB. Cosine of AB is cosine of adjacent sides, that means cos of 110 and cos of 55. So let me write here cos of 110 and cos of 55, plus then I can write like this, sine of 110 and sine of 55, and cos of this angle, which is P. Well, this is nothing but the D long, which is 145 degrees. So this is 145 degree. Now all I have to do is to evaluate this equation, and I can do it here, that cos AB is equal to, well, for this I can simply use this calci. Let me just switch it on. So let's punch. This is cos 110 multiplied by cos 55 is equal to this plus sine 110 into sine again 55 into cos 145. So I get this product which is in minus. All I have to do is just shift and cos inverse, so I get this value which is 145.76, and I can use this as 145.763. Well, I need to multiply, and then I multiply with 60, so I get distance like 8745.78. I can round off and I can write the distance as 8745.88. I can write the distance 8745.78, or we can round off this simply 8745.8 nautical mile. That is the distance I get as AB. Now this distance AB and a degree is 145.763. We'll take that. So let me just put here 145.763. Well, after multiplying, I have already calculated this distance, but now let me write this value in degree. Now we need to find initial cos, so I need to find this angle. Well, this angle can be obtained by using this formula, that this side cos PB, let me just put it this way, cos PB is cos of this side, which is cos PA, and cos of this side, which is cos AB. Similarly, sine PA and sine AB into cos A, that means this angle, into cos A. Well, I have to do is I need to bring cos A this side, so I can write like this: cos A will be cos PB minus cos PA and cos AB divided by sine PA in sine AB. Yeah, it's just a little bit algebra. And now I can start putting the value that cos PB was 55 degree minus cos PA 110 into cos AB, which is 145.763 degree. I have taken this value, divided by sine PA, again 110 degree, into sine AB, which is 145.763. Just to be sure, cos PP is 55, so P and B, this is the 55 I have taken. Well, all we have to do is now just put in the calculator. And how to do it? Again, I can use the same. Just first let me cancel it. So let's start with, first we should start with cos 55, then I put minus, then I can put bracket, I think that's better, then I can write cos 110 into cos of 145.763 bracket close is equal to answer. Now divided by, I simply start with the bracket sine 110 into sine 145.763 bracket close. So I get this value, which is 0.550083. This is the value of cos A, so I put inverse, shift and this is cos of inverse, and I can put it in degree, which is 56 degree 37 minute and 38, or divide by 60, I get 0.6 closest one decimal, so I can write the value as 56 degree 37.6. so 56 degree 37.6, this is the closest value I get. This is angle A, and let's find the direction. Well, you are going in this direction from A to B. This is north and easterly direction, so again this is north and this is east. So this is the initial course. Now let's find the final course. So for final course, let's come up here. Final course, I need to find first angle B, and again I'll be using this formula that this side, which is cos PA, is equal to cos of this side, which is 55, and cos of AB plus sine of this and sine of this and cos B. I can simply write like this, that cos B will be cos 110 minus cos 55 and cos of 145.763 divided by sine 55 and sine 145.763. Let me just correlate with this one. So this was PB. Now I've replaced with the PA, which is 110. Again, this is PA, which is 110, and this is PA. So this PA I replace with PB, which is 55. PB is 55. So I get this cos B. Well, again I can use this calci, and let's start punching in the calci. This is cos 110, then minus, bracket starts, cos of 55 into cos of 145.763, bracket close, answer divided by, again bracket, sine of 55 into sine of 145.763, bracket close. So I get this value 0.28, and now this is cos B, so I need to find the value of B. So cos inverse, I get this 73.33. well, round off, 73 degree 20 minute 6.2. so this 6.2 I can write as just 0.1. so my angle B is now 73 degree 20.1. This is angle B I got. So let me go up here. This is the angle B we have obtained, and now we have to find the course. So if the angle B is this, so we have this angle, I have obtained this angle B, and this means that suppose this is your meridian, that means this line, and the ship is somewhat like this. So the angle obtained is this angle, which is 73 degree 20.1. This is the angle obtained. Now this is north, this is south. Well, we can mark east and west also. So this course is now north 73 degree 20.1 minute west, because we are taking from this, but this is wrong. The course is the final course is I am interested in this one. So this course will be, I need to subtract from 180 degrees, so this is wrong. So it is going to be 180 degree minus 73 degree 20.1. So simply 180 degree minus 73 degree and 20.1 degree. So I get this value, which is 106 degree. Let me just go up here. 106 degree 39.54 second, which is 0.9. 39.9. This is the angle, this is the course, and that I can write in true course. Or if I need to put in the value of south, then this angle is also equal to this angle, which is 73 degree 20.1. So I can write that the final course is south 73 degree 20.1, east, or in 3 degree notation this is 106 degree 39.9. Well, the course has to measure from this north and south line. Let me use this color, this north and south line, this line, which is this line here. This is the meridian. You got to be careful. And since ship has moved in this direction, now the ship's heading is this. We found this angle